presentations, please feel free to ask a question with the Q&A or chat function of Zoom. We'll try to monitor this chat, and so if I cannot answer the question in my session, maybe Cormac or Duncan will answer it, or we'll wait till the end of the first presentation. Same goes during Cormac's session and during Duncan's session. So please feel free to ask questions whenever a question pops up. So the agenda for this initial session is the introduction of containerized workloads in your data center. And we expect that to happen. So the next question is, how can you create a platform that allows other people other than the infrastructure administrator to use the vSphere platform, and so to create a self-service platform and allow you to consume it. Now, the third question that pops up is, how can you make sure that you're not introducing noisy neighbors in your environment, and so the developers can safely consume the environment? And so you have to build, or you have to think about a consumption strategy. So let's start off with the introduction of containerized workloads in your data center. So what we've seen while talking to our customers for the last few years is that we see more and more containers entering the data center and replacing the commercial off-the-shelf software. So we're talking about software that is installed via a DVD or installed via an executable. And so that's slowly replaced by containers. And IDC, a analyst company, they looked into it and they generated a report. And within that report, they predicted that over 500 million cloud native applications are expected over the next 5 years to land in enterprise data centers. Now that's quite a lot of new workloads, and it might sound a little bit ludicrous if you think about it, but when you look at the newer types of development and the newer type of applications, let's use machine learning, for example, it's not such an insane number, because with machine learning, you use data and you create a model and you train that model with the data to get a prediction. Now, to get that data into that model, you have to create all these pipelines, data pipelines or model pipelines, and each step within that process is actually a microservice which typically runs in a container. So a normal machine learning application typically consists of a data pipeline with 30, maybe even 40 containers just to get this prediction going. And so when you look at that and the amount of newer machine learning applications on the horizon, that 500 million number doesn't actually sound so absurd anymore. Now, maybe you say, but look, when I hear about containers and I hear about cloud native applications, typically developers are talked about. I don't have any developers in my organization, so is it realistic to see a container in my data center? Well, the interesting thing is that a lot of software vendors are looking to containers as a unit to distribute software. So we're talking about, for example, SAP, who uses their new processes and their new applications. They bundle it in a container to have it deployed by their customers. So even if you don't have developers, there's a big chance that you will see containers in your environment. And that led us to the next question. So how does a modern application architecture actually look like? Because everybody, if you look at the media and they're talking about containers, it's all about containers and nothing else. And everything else is old, is legacy, is done and dusted. But in reality, that is not true. Because yes, you're going to create a new application and it possibly will be a containerized application, but it cannot run in a vacuum. It has to run somewhere, and it has to interact with other things. So you have this containerized application. Now what? Now, typically a cloud native application is of a distributed kind, meaning you're not creating a single container, you're creating multiple containers in order to run that service or that application. And thus, you need to have a system that actually can orchestrate the whole life cycle and the operation and high availability and all those type of things for that application. So one platform that is excellent for that is Kubernetes. Now, Kubernetes consists of multiple nodes. You have the Kubernetes control plane that consists of many nodes that allows you to run like these operators and all these services to make sure that the applications are spun up on a particular worker node. So the worker node actually executes the application, but the control plane makes sure that it will run that application. And if something fails, the control plane will make sure that the application is started somewhere else, right? So that's, in a nutshell, that is what Kubernetes is all about. Now, if that is basically the thing what you hear in the media, but is this the end state? Well, no. And so let's take a bank app, an online bank app, for an example. So you have created this online bank app, and now you want to have customers access that bank application via the web. But you need to make sure that not everybody can access that application, because you only want to provide that service to your customers. So you need to have this online bank app connected to your customer database and to the accounting service, because they need to access their accounts. And typically those type of services, they run in virtual machines. They have been running in virtual machines for a long time, and we bet they will run in virtual machines for a long time after this presentation. So you have this mix, a modern application architecture that consists of containerized applications and the traditional application and databases and what have you. And so we have to look at the responsibilities and the questions that like a developer and an IT ops team can generate. Because for the developer needs to think about, okay, how can I deploy this app, and how can I connect it to those traditional applications, and how do I make sure that if that application runs and something fails or something is updated, it will still provide those services to the customers. And what type of tools can I use? Can I see those virtual machines, those applications somewhere else? And so for the IT ops team, it's all about, okay, so how can I ensure the availability of the complete app, not only the traditional applications and the databases, but also now that containerized application? And how do I ensure its security? How do I deliver quality of service? Because we want to make this application run great next to the traditional virtual machines. And how do I control the cost of the infrastructure? The developer can want to have like a Kubernetes cluster, but how do I make sure that environment won't become a big and noisy neighbor? So we thought about this, and we have actually been working on creating a solution over the last couple of years. So Kubernetes was actually released in 2015, and we released Project Hatchway in 2017 that provided persistent storage volumes to containerized workloads. In 2018, we released NSXT 2.x that provided network policy, containerized or container L3 networks, and different types of microservices. In 2018, we required Heptio, and that allowed us to get the brain share of two of the original founders of Kubernetes. They invented Kubernetes at Google in 2015, and they started the new company Heptio, and we acquired them. Heptio also had a very interesting upstream compliant Kubernetes distribution. And in 2019, we announced at VMworld vSphere with Kubernetes, which now is called vSphere with Tanzu, but Cormac in his session will go into the finer details of this. So that allowed us to create this environment that provided different ways of delivering containerized applications. So we have vSphere 7 with Tanzu that allows you to run a container as a native construct within the hypervisor. And then we have Tanzu Kubernetes Grid Services, TKGS, that allows you to spin up Kubernetes clusters inside virtual machines on top of the vSphere 7 platform. And TKGS is the functionality, the product that we're mostly talking about during this roadshow. But let's take a brief moment to go over that native construct offered by vSphere 7 with Tanzu. And that is called a vSphere pod. And so a container by itself is actually just a collection of processes. So in order to run a process, you need to have an operating system. Now you can run containers on a Microsoft operating system, but the majority of containers in our world are actually run on a Linux operating system. Now, ESX is neither, can we mute somebody? Because I'm getting an echo here. Okay, so ESX is neither a Microsoft operating system or a Linux operating system. So we need to get this Linux operating system run inside ESX. Now, what better option than to use a virtual machine? So we created this lightweight virtual machine that allows us to run a lightweight Linux operating system, Photon OS, to create this secure environment that is shielded away from everybody else or from every other container. By using only para-virtualized devices, we have this insanely low footprint for the pod VM. So it's a really lightweight virtual machine running on or running inside vSphere. Now, we create our own container runtime, and that allows us to interact with the pod VM, and you can spin up containers in that pod VM. This is just a brief overview of how a vSphere pod actually created. But like I said, most of the time we're looking at TKTS. So that's the act of running a Linux virtual machine with Kubernetes on top of vSphere. Well, of course, a officially supported and upstream compatible or compliant distribution of Kubernetes. So if you have that in mind, vSphere 7 with Tanzu and TKTS, you're able to create this self-service platform for developers. And the key is that it allows you to still centrally manage that platform with your current toolset. So with your vCenter, with your vRealize suite, with your automation tools. And this is the interesting thing, is now we allow other people, other employees or customers to deploy workloads on that platform. But now you need to think about creating this self-service platform that allows others to consume the resources safely, and so allow you to create this multi-tenant environment. Now, if you want to use vSphere 7 with Tanzu, you have to basically enable it in vCenter. But the interesting thing is, if you go search for the term Tanzu in vCenter, you won't find any, because the actual functionality within vCenter is called workload management. And if you go to the menu, you'll find workload management, and you will get presented the screen what you see on the left of the slide. Now, Cormac will go over the details on how to install this, but Cormac also has this a very detailed write-up on his blog. So go check that out after this roadshow. Now, once you go through all these steps, you will see the screen that's presented here on the right side of your screen. And that is, you see your cluster. And now there's this resource pool called namespaces that automatically appears. And below this namespaces, there are 3 control plane VMs, which actually runs the full control plane of a Kubernetes cluster. And you're going to use that Kubernetes cluster to deploy other Kubernetes clusters. So the combination of Kubernetes with vSphere enabled inside a vSphere cluster is what we like to call a supervisor cluster. So that supervisor cluster will become your springboard to create other Kubernetes clusters that are available for your developers or for any other business unit that wants to run Kubernetes. And so the reason why you'll see 3 is something that I'll explain later during this presentation. So with that in mind, we have this Kubernetes control plane, and now a developer, for the first time ever, can actually interact with vSphere using their own tools, so their own command line interfaces and their other tools. And so it becomes this self-service platform, similar to what you see with Amazon, where a developer logs into a website and clicks through all the different settings in order to generate a particular Kubernetes cluster or a particular EC2 instance, and same goes for Azure, of course. But here they can just from their own workstation on their own network connect to the vSphere platform and use their own tools to interact with that platform to deploy their own workloads. Now, this may sound a little bit frightening to infrastructure admins, saying that, hey, I just handed over the keys of my vSphere platform to a developer. They are not really infrastructure savvy. They don't really understand the infrastructure side of the things. I want to control it somehow. And we introduced what's called a namespace in the vSphere platform. And that allows the infra team to actually control the particular services and resources consumed by the developer from the vSphere platform. So in order to do that, you have to create this namespace. And if you go into workload management, the thing that you just configured, now you have the ability to create a namespace. So if you click on that, you will have the screen, you will be presented the screen on your right. You select the cluster, you give the namespace a name, you select the workload network, and you click on create. That provides you with a new icon in the host and cluster view, and I call it online bank app, and here you see it. And if you click on that, you will see this summary page, what you see on the right. And now this summary page will easily show you all the things configured. Now I still need to configure the permission and the storage. So with the permission, I as an infrastructure admin can select the users that can actually deploy workloads in that particular namespace. I need to select a storage policy for the virtual machines to consume, so for the Kubernetes environment to consume. And if I selected both if I configured the permissions and I selected the storage policies, then I have the option to set a physical resource limit. So in this case, I set a 50 gigahertz limit and a 64 gigabytes memory limit. And the beauty of this is that in the summary page, you immediately see those limits applied. So in one overview, you have this view where you can see all the quality of service provided to this particular namespace. And so you have to see that namespace as a collection of applications. You can run your TKT clusters in it, but you can also deploy other virtual machines into this namespace. And so once this is done, the developer can start to deploy their own TKG clusters by using their own tools again. So how do you start working together with the developer that they can safely deploy their workloads that can perform, that provides the provides the availability that they want, but not to have this platform be consumed by just a few developers and see all these noisy neighbor consume your vSphere platform. So you have to think about a consumption strategy. Now, in order for the developer to deploy a Kubernetes cluster, they have to create this YAML file. And again, Cormac will give you a little bit more detail about this. I will just briefly look into that. So if we zoom into that deployment YAML file that actually deploys a Kubernetes cluster, you notice that you need to provide a virtual machine class for the control plane nodes and the worker nodes. You also have to provide the number of nodes that you want to deploy. Now, this is just a very simple YAML file. Typically, a YAML file contains many more options, but I just wanted to show you these. I would just want to highlight these settings. Now, when we talk about virtual machine classes, there are actually 16 different virtual machine classes. Now, let's zoom into that a little bit more. So here you have two types of classes. You have the best effort class and the guaranteed class. Now, best effort basically says it all. You're going to be able to deploy a workload on your vSphere platform, but if there are no resources, you're out of luck and you basically use your shares in order to get some of the resources if there's contention. If there's no contention, you will get the resources that you want. Now, that is perfect for workloads that are used for testing. So a Kubernetes cluster that is used to develop a application. But if you have a Kubernetes cluster that actually needs to run production workload, the best way the best virtual machine class is the guaranteed class, because you're applying automatically a CPU reservation and a memory reservation that's equal to the virtual machine class size. Or if we dig into that, let's say we're looking at virtual machine class size large, you will see that that virtual machine will get 4 vCPUs and 16 gigs of memory. So it also gets 4 vCPUs of reservation and 16 gigs of reservation. With that in mind, we have to think about, hey, maybe I don't want everyone to actually deploy guaranteed classes, and maybe sometimes best effort classes are better. So you have to think about your cluster configuration footprint. Now, the thing here is you're creating a self-service platform. So you're not a part of the deployment process anymore. So you have to become like an advocate, or you have to provide tech talks to your developers saying like, look, these are the things that needs to be done if you want to deploy it on this platform. So one of the things that you can discuss is how many, from a control plane perspective, how many nodes do you actually want to deploy, and how big is that control plane? Now we have all these sizes, but what is the correct size? Now, typically the size depends on how many operations are expected. So if you have like this development Kubernetes cluster that often, or just sometimes see a particular container be deployed, you don't need to have the largest control plane node size, because typically the size depends on the operations. If there's no thing going on, and if like the application is being spun up and being deleted again once in a while, you're fine with a smaller one. But if you have like this massive production environment with a lot of churn, saying that, hey, we're spinning up a lot of containers and we're deleting them again on a day-to-day basis, maybe even hourly, you want to have more resources available for the processes inside the control plane node. Now, from the virtual machine class, I already discussed that. For interactive test, typically best effort is, okay, for production, you want to have consistent performance. So guaranteed might be the best solution for you. So for consistent performance, use guaranteed resources. Now, those reserved resources actually impact the consolidation ratio of the supervisor cluster, because think back to vSphere HA, where you have percentage based or you have slot based, and that depends how many VMs can be powered on with the host toleration factor in mind. Now, the control plane of Kubernetes also have this high available notion. So it becomes this mix and match scenario, because in order to deploy a vSphere, in order to deploy a container, a pod on your worker nodes, you need to connect to the API server, or your CI/CD pipeline need to connect to the API server. And that instruction is actually saved inside the etcd database. etcd database is a key value store, and it's a quorum-based system. So that means that there needs to be a majority of nodes still available in order to have it run. Now, once it's stored there, all those controllers and those scheduler will do what's necessary in order to make sure that that container runs. So that etcd database is very important. Like I said, it's a quorum-based system, so that's the reason why you always see an odd number. So if you have 3 control plane nodes, you actually can tolerate a single control plane node failure. But maybe for some developers, that's not enough. So they want to have 2 control plane node failures to tolerate. That means that you need to spin up 5 control plane nodes. Now, if you have a really risk-averse developer, or maybe a business unit wants to run production environment, and they say, I want to be absolutely sure that it can fail a couple of times, you can spin up to 7 control plane nodes, and that can tolerate up to 3 node failures. But the interesting thing here is, think about vSphere HA again, because if we dig into a little bit more deeper into the Kubernetes high available timeline, it will typically take up to 350 seconds for Kubernetes to respond to a failure. Now, the reality is that within 60 seconds, vSphere HA already has that virtual machine up and running again, or restarted. And so you can mix and match those two, providing the ability to run a high available control plane from a Kubernetes perspective, but then trust on vSphere HA to restart and do the right thing, and to be a little bit more aggressive with the response time. So for the worker node perspective, you have to think about, what does the container actually need? How many resources do I need to run, or do I need to provide to that containerized application? Now, the number of worker nodes actually is how distributed is this application, and how many failures can I tolerate? Because a Kubernetes worker node is a soft fault domain. What I mean by soft is that Kubernetes will always try to deploy the pods on separate worker nodes. So if you have 3 worker nodes, and if you have a containerized application with 3 replicas, each replica of that application will be powered on a separate worker node. But if you have 6 replicas with 3 worker nodes, Kubernetes needs to be able to spin up those 6 worker nodes, 6 containers, and thus it will spin up 2 containers per worker node. So that's the reason why I call it a soft fault domain. Now, with worker node consideration, this is where it actually really comes down to, are you doing production or do you test? Because for a production environment, guaranteed is the recommendation because of the consistent performance of your actual application. Now, namespaces are backed by resource pools, and that means that if you run this environment with multiple other virtual machines. So you're spinning up virtual machines next to your TKG clusters. Maybe it actually start to make sense to investigate resource pool for your virtual machines as well. Because now a monster VM can actually overpower all the other TKG clusters, all the best effort TKG clusters, because it competes with its size to the namespaces resource pool folder. And so introducing resource pools will level that field a little bit. Now, interestingly enough, in vSphere 7, we introduced scalable shares, which allows us to dynamically calculate the share value of resource pool folders, and so create a more better way of distributing those resources. Now, explaining scalable shares will take a half an hour for me as well, and so I published a deep dive on my website, frankdenneman.nl. So if you are interested in the functionality of scalable shares, please check that out. So the last thing that I want to share with you is when you go talk to your developers or with the business units that want to deploy containerized applications, ask them questions about the Kubernetes landscape. Are you going to develop on a high pace? Are you going to run and destroy containers on a day-to-day basis? If that's the case, maybe you have to think about separating your environment in a separate vCenter, because if you have a lot of developers doing a lot of things, you might be basically seeing a different types of noisy neighbor, and that's the number of operations on your vCenter. So maybe do the same thing with VDI, create a separate environment for your containerized workloads. Now, the last thing that I want to say is that three control plane node structure is very interesting to look at from a resource consumption perspective. We provide a number of virtual machine classes, so you're stuck at this point in time with the types that we provide, and so that allows your developer to select a particular namespace that might not be efficient in your platform. So have a conversation with your developer and help them understand what they're doing and how it actually helps them to right-size their environment. And with that, I would like to thank you. So the next session will be Cormac, and Duncan will finish up the roadshow. So guys, are there any questions?
There was one question, Frank. It's basically a comparison to the TKG multi-cloud product and the supervisor cluster. So there is a management cluster in TKGM, which does a similar sort of thing to the supervisor cluster. We're just clarifying that, and I'll be touching on that at the beginning of my session as well.
Nice.
So what I can do, I can unmute, can allow the participants to unmute themselves if they want to ask a question or whether they want to type any further questions into the chat window. And of course, if you think of something while I'm talking, absolutely use the chat window as well, and Frank and Duncan will be able to assist you there.
Well, I stopped sharing, so you can start your presentation, Cormac.
Thank you, birthday boy.
Yesterday, dude. Yesterday.
Cool. Yep, so if there are no questions, I will proceed. I'll follow on from Frank. Probably gone one little bit too far forward here. There we go. That's what I get from messing with the presentation while Frank was speaking. So it's still not at the beginning. There we go. So this is what I was planning to talk to you about this morning. So really, this is going to be more of a sort of hands-on demonstration session. Frank has given us a load of background now on vSphere with Tanzu, the supervisor cluster, the namespaces, the TKG guest clusters, all of that good stuff. So I'm going to delve into it and show you primarily the process on how you can set this up for yourself. So I did want to start with what I plan to talk about. Now, there was a lot of, I think there still is a lot of sort of confusion about what works with what and what are all these different Tanzus that we have out there and what components do I need, which vSphere components do I need in order to stand up vSphere with Tanzu. So I'll spend a little bit of time on that. The deployment steps I'm going to go through, I'm going to be predominantly talking about the HA proxy load balancer appliance, which is a requirement. Certainly a load balancer service is a requirement. And for those of you who just want to do proof of concepts and want to set this up in home labs, things like that, the HA proxy is the easiest way to do it. So I'll go through the steps involved in that. We'll go through the enablement of what we call workload management, which is essentially standing up the supervisor cluster that Frank talked about. And then we'll go through the deployment steps of a guest cluster, a TKG guest cluster. So again, this TKG, short for Tanzu Kubernetes Grid, we see Tanzu used all over the place. So I'm going to try and qualify in some detail what we're actually talking about here and which flavor of Tanzu we're talking about. And then finally, I want to close off, and this is a good one to introduce Duncan's session as well on vSAN, is to talk about a vSAN service, the data persistence platform that we now have available on vSphere with Tanzu as well. So let's go and talk about what the difference is with this vSphere with Tanzu, what you might have heard termed VCF with Tanzu, and what are the requirements. Before I even get into that, like I said, this term Tanzu is bandied about a lot. And right now there's 3 different flavors of Kubernetes that you can get from VMware. And they're all under this Tanzu umbrella. So the first one is the one that's been around for some time. And this is the TKGI, which you might remember was the former enterprise PKS product, the Pivotal Container Service. So that is now TKGI. I will not be talking about that in this session. The second one, and it was a question that Valerio asked on the chat, was about TKG multi-cloud or TKGM, Tanzu multi-cloud. So this is the version of Tanzu where you deploy out a management cluster. So it's Kubernetes as a management cluster, and then you use this management cluster to be able to deploy out a Kubernetes workload clusters. The thing with the multi-cloud is, like the name says, you can deploy it on vSphere, but you can also deploy it on different clouds as well. I am not going to be talking about TKG multi-cloud. What I will be talking about is another flavor of TKG, which appears in vSphere with Tanzu. vSphere with Tanzu has a service called the TKG service. And in many ways, it's similar to TKGM insofar as you can use it to provision workload or guest TKG clusters. So that is what I'm going to be talking about in my session, is the vSphere with Tanzu and the TKG service. Okay. So let's build it out. Again, this is just reiterating what Frank mentioned in his session. So we have this vSphere infrastructure. On top of that, we enable workload management. I'll show you a demonstration of that shortly. That rolls out the supervisor control plane. With that supervisor control plane, then we can go ahead and we can build namespaces. And as Frank has shown us, these namespaces can have different resources and limits and so on associated with them. And typically what you would do is you would give this namespace to a developer or a group of developers, development team, and they can work inside here as much as they like without stepping on developers working in other namespaces. So once we have the namespace, what are the kind of things that we can put into a namespace? Well, if you're familiar with the original vSphere integrated containers, the VIC product, there's a similar concept called a pod VM now, which is a container workload, but wrapped inside in a virtual machine. So you get the agility of containers, but the security and isolation of a virtual machine. So that's one type of application you can roll out here. But to be honest, the major use case is the ability to roll out these guest clusters within the namespace. And it's not just a single guest cluster, you can actually have multiple guest clusters inside in a namespace as well, depending on the resources. And as Frank said, there's still a massive role for the vSphere administrator here in order to manage resources and making sure that developers don't do something weird and wonderful within their namespace and impact others. Alrighty, so when we launched vSphere with Tanzu back in the 7.0 timeframe, the first thing we had was a requirement that you could only have it with VCF, so vSphere Cloud Foundation, or VMware Cloud Foundation, beg your pardon. And the reason for this is that you can see here that there's a whole bunch of, well, VCF is basically your easy button for standing up your SDDC. And when we talk about the SDDC, we're talking about your compute with vSphere, your networking with NSXT, storage, vSAN and other storage can be used. And of course, you have all the management and monitoring via Realize. Within VCF, and the reason we went for VCF is that there was a requirement to have all of these different services. So we talked about the pod service already, the ability to create these pod VMs, but also storage service. How can Kubernetes objects consume vSphere storage? And so we have a driver there that allows us to do that, integrated into Kubernetes. There's also the network service. So here there is a requirement to provide load balancing services. There's also requirements for tunneling and overlays so that pods can communicate to each other. And all of that was provided by NSXT. Last but not least is the registry service. This is a container image service, an on-prem container image service. So rather than your developers having to go out and download from some third-party image registry, you can actually maintain your image registry on site. So there were a bunch of services that we needed to have, and VCF was the best way of providing these services initially. But of course, the other service as well, which I've talked to you already about, was the TKG service, the ability to roll out these guest services. And so all of this is wrapped around APIs, and developers can just use a standard Kubernetes manifest files, send it to the API, the control plane API of the supervisor cluster, and consume these services as they need them. But as you can see, there's a lot of requirements here. Not every customer has VCF, not every customer has NSXT, not every customer has vSAN. And so what then happened was with both the 7.0 U1 release and the 7.0 U2 release, we relaxed a lot of the requirements. So you no longer needed VCF, you no longer needed NSXT or vSAN, but that had an impact on the available services. So for example, NSXT is the only network service that provides the overlay and tunneling. And so if you did not use, or if you do not use NSXT, you don't have the pod VMs. And so if you don't have the pod VMs, you don't have the Harbor image registry service either. So just bear that in mind. So let's just comparing them side by side. With vSphere 7.0, we had VCF with Tanzu. That was VCF, NSXT, and you pretty much had everything that was available in vSphere with Tanzu there. With 7.0 U1, we introduced the HA proxy appliance for the load balancing service. And so you can now use vSphere with Tanzu without VCF, without NSXT, but the knock-on impact of that is that you don't have the pod VM service. And so since you don't have the pod VM service, you don't have the Harbor image registry service either. The one thing about the HA proxy is that it wasn't a VMware product. It is a third-party product that we did some engineering on. And so with the release of vSphere 7.0 U2, we now have our own VMware engineered load balancer. And this came from the Avi network acquisition, I think was last year. And this product is now being marketed as the NSX Advanced Load Balancer. And so again, with 7.0 U2, you have a choice of load balancers. You could still use the HA proxy. You can use the new NSX Advanced Load Balancer, or actually you can still use NSXT if you wish. But the point is, if you don't use NSXT, you don't get the pod VMs and you don't get the Harbor image registry. Okay, so that's just comparing those side by side. I'm not going to go through all of these. There are a number of requirements that you do need to, set aside if you're going to go ahead and enable vSphere with Tanzu. And in fact, the workload management UI shows you all of these requirements if you go ahead and you wish to enable it. So it's all displayed there in the vSphere client, but I'm just listing them for you there as well. So now I'm going to go through the steps for deploying the HA proxy. And really, I mean, you can absolutely use this in production, but I think that a few things. One, it's not VMware supported, so maybe that could be an issue for you. I mean, we absolutely support the load balancer service part, but if anything else goes wrong with that HA proxy, you need to get support somewhere else. But I think the recommendation we'll be making now, since the release of 7.0 U2, is that you would use the NSX Advanced Load Balancer if you're going into production and you're not using NSXT. So there are two ways of deploying this load balancer. Again, let's have a look at our vSphere environment here. We have our management network, obviously, and then we have this workload and front-end load balancer network. And the workload network is where all of the Kubernetes clusters would sit. The load balancer network is how your developers would connect to those Kubernetes clusters. So essentially what we do is we wrap all of those nodes in the Kubernetes cluster in a virtual IP front end, and so that if anything happened at the back end, such as a node failing or rolling upgrades or anything like that, you're still connected to the virtual IP, so your connection is not impacted. Now, when you roll out the HA proxy, you can do it with two network segments, the management network and a combined workload and front end network. Or more commonly, what you'd see it rolled out as is three network segments, where again, the management network, but you would separate out the workload network where the Kubernetes and nodes live, and then the front end load balancer network where your developer would connect to your Kubernetes clusters. The important point here is that there needs to be a route between the front end and the workload networks. So it comes as an OVA, this HA proxy comes as an OVA. As I said, we did some engineering work on it. And basically what you do is you decide whether it's a 2-NIC approach or a 3-NIC approach, and then you just populate all the different requirements around networking. Remember, this is going to provide your load balancer. So what it provides your load balancer service. So what it does is it allocates IP addresses on the load balancer front end network. A lot of considerations that need to go into vSphere with Tanzu. For instance, what is the range of IP addresses that you're going to use for your front-end load balancer network? Also, the supervisor cluster that needs to sit on both the management network and the workload network. So you need a contiguous range of 5 IP addresses for your supervisor nodes. So they need to be set aside as well. And the last consideration then is to do with the workload network. So not only do your supervisor cluster nodes sit on this, but also your Tanzu Kubernetes Grid guest clusters sit on this workload network as well. So another range of IP addresses needs to be set aside for that network. And you'll be populating this information in various places. You'll be populating some of it in the HA proxy, and you'll be populating the rest of it inside in the workload management section, which is what we will see in a moment. So it's worthwhile spending quite a bit of time just getting all of this, written down, considered up front before you go ahead with the deployment. Now, I use these two tools all the time. One of them is a CIDR calculator, so I can figure out what ranges of IP addresses matches to a CIDR range. That's just one example that there are many of them out there, but this is just the one that I use. And the second thing is, once the HA proxy has been deployed, all of the IP addresses on the load balancer network that it is going to service should respond to pings. So in this example, I'm using an IP scanner. It's called the Angry IP scanner. I don't know why they picked that name, but it seems to work quite well. But the point is that if your IP addresses in the load balancer range are not responding to IPs, there's no point in proceeding with the workload management deployment. You need to go back and figure out why the HA proxy is not responding correctly. And so just lessons learned. These are tools that I use all the time to get things just right. So assuming the HA proxy has deployed successfully, we'll end up with something like this in the 3-NIC approach. We'll have the HA proxy on the management network, we'll have a HA proxy with an interface on the workload network, and we'll have the HA proxy with an interface on the front-end load balancer network as well. And remember, I can stick the Angry IP scanner onto the front-end network, and the range of IP addresses that I set up on the HA proxy should all respond. Another very useful test to make sure that the HA proxy is running successfully or working successfully is you can point at this URL here. So the HA proxy port, the load balance port is 5556. You should be prompted for the username and password that you provided during the OVA deployment, and you should actually get some API information back. You can see it there in the lower part of the screen. So great, let's assume the HA proxy is now working successfully for us. So if we have the HA proxy working, we can now go ahead and enable vSphere with Tanzu. And essentially, we now have a new menu item or inventory item in vSphere 7.0 and later, which is workload management. And if you select workload management, you can see there, you can select the different networking stacks. And I'll show you a demonstration of all the rest of the information that we need to input. Essentially, what you're doing is you're providing all of that network information that we talked about previously. Now, what should happen is that we get the 3 supervisor nodes rolled out. Those supervisor nodes will sit on the management network, and they will also have an interface on the workload network. And when everything is communicating correctly, the HA proxy should provide a load balancer IP address, and you should see that change in the workload management view there when the workload management has completed configuration successfully. And you can see there a change in the IP addresses. So this is obviously the first one there is actually on the management network initially, and then when everything is communicating and everything is working successfully, it gets reallocated an IP address, a front-end load balancer IP address, which is what your developers would use for connecting to the cluster. So what should happen if everything is successful and we've enabled workload management is we get the 3 supervisor nodes on the management network. We get them plumbed up onto the workload network as well. And of course, we get the supervisor control plane API address, load balancer address, and that's what your developer would use to communicate to the supervisor cluster. Okay, so let's have a look at a demonstration of this in action. So here we are with workload management. Assume that we have HA proxy already set up. We are going to use vCenter networking, not NSXT. We're going to select the cluster. I have only one cluster, so that's pretty straightforward. We're going to select the resource type or size for the nodes in the supervisor cluster. Frank spent a lot of time discussing that with us. And we're now going to select a storage policy as well. It doesn't necessarily have to be vSAN. It could be any storage policy or any backing storage. And now we get into the networking. And now we're talking about the load balancer network, which is provided by the HA proxy. And you can see the usual information being filled in there, along with the range of IP addresses. on which we are going to provide the load balancer service. So again, those IP addresses will be consumed by supervisor cluster, guest clusters, and any applications that require a load balancer service. This is the management network. These are for our 3 supervisor nodes. Remember, we said they need 5 IP addresses, and you give the starting IP address here. And it's just the usual networking information then after that. Final network is the workload network. This is again where the Tanzu Kubernetes Grid guest clusters or workload clusters that we deploy. This is where they come up. And you're basically just selecting a port group, giving it a name, gateway, subnet, and IP address range once again. Great. Last but not least, we just need to add a content library, and the content library is a subscription content library which downloads all the images for the different nodes. So the supervisor nodes, TKG guest nodes, all of that good stuff. Okay, so we can speed things up. It usually takes between 5 and 10 minutes for this to come up. But what we should be able to observe are the supervisor control plane VMs appearing there, as you can see. This currently only has 1 IP address. This has the 2 IP addresses. I mean, there's IPv6 and IPv4. And then this one has a 5th IP address, which is the etcd key value store IP address. It gets its own one. So again, it's on 2 different networks, which is good. And we're still waiting for this one, but it will come up. We can speed things up once more. So the whole point is that when they are all successfully communicating, we get allocated an IP address from the load balancer service, which you can see there, and our cluster is up and running. So now we can build these namespace constructs that we keep talking about. And Frank has given us a lot of detail about this as well. Again, you just give it a name, which network it's on, because you could have multiple workload networks. And you just tweak it, adding your permissions and so on. The nice thing here is that you can point your developers at this namespace URL as well, and they can download all the tools that are necessary to interact with vSphere with Tanzu. Storage, this is just making anything that is created within this namespace will get one of those storage policies that you've configured. Frank has given us a lot of information already about the limits that we can set up and how important these will be to avoid developers stepping on each other. And at this point in time, we don't have any Tanzu Kubernetes Grid guest clusters, but we're going to change that because we are going to create a guest cluster next. So that hopefully, along with what Frank has given us previously, should hopefully give us a good idea of what we do with a namespace. As I said, it's a way of getting tools to interact with vSphere with Tanzu. It's a way of looking at the status, assigning permissions, setting up what storage you're allowed to access and consume, and then setting various limits about CPU memory and so on, and storage as well, of course. And then last but not least, it's the Tanzu Kubernetes, any Tanzu Kubernetes Grid guest clusters or workload clusters that we deploy within the namespace, they will show up in the final view there. So how does the developer interact and create objects and so on? Well, to access the supervisor cluster namespace, there's a kubectl vSphere login like we're showing there. And when you provide that, I mean, I'm using administrator at vSphere.local. Maybe that's not the one you would give your developer. You would give them their own unique username. But once they drop in there, they're able to, they'll be working within the context of various namespaces that have been created and they've been given permissions to access. So from within here, I can now request a supervisor cluster or request the TKG service on the supervisor cluster to create me a guest cluster. How do you do that? Well, a guest cluster is just another object. It's so you would access it by, or you would create it by creating a manifest file using YAML, yet another markup language, basically how everything works in Kubernetes. And here's an example of how we could create a guest cluster. So you can see you can set the control plane. This is the number of control plane nodes. This is where Kubernetes, in essence, would run. And then the worker nodes, this is where your applications would run. And then the class, of course, guaranteed small. Frank talked a lot about the different classes that we have as well. So you just need to keep an eye on those. And then finally, which distribution of Kubernetes are we going to use? And all of these distributions are held in your synchronized content library. So you can list those out and you can select which one. You can use shorthand, as you can see there. So you would just apply that using the kubectl command, apply it. It goes to the supervisor cluster, it goes to the TKG service, and that would deploy out the guest cluster for us. So assuming that all works, what we end up with is something like this, a guest cluster, 3 nodes, again, 3 virtual machines. These sit on the workload network, like we configured that workload network and talked about that a number of times. But again, the TKG control plane would have a front-end API server load balancer IP address. Now, you might say, well, for one node, it probably doesn't make much sense to do that, but this is how Kubernetes works. And of course, you can scale out the control plane, like Frank says, to just be 3, 5, or even 7. And so then it becomes a lot more makes a lot more sense to have that load balance front end, because if one of those nodes fails, it'll be transparent to the developers that are using it. So how do we access that guest cluster? And there we go. We can see the login there, but there's a few additional options. There is the namespace option, and there's also the cluster name. So you can see those there. Now, what that does is will drop you in to the context of the guest cluster now. So now any objects that you create will be against the guest cluster. So all of your interactions, your kubectl interactions, will be against the guest cluster and not the supervisor cluster. I have one more short demo. And this demonstration is just showing you we have the namespace built, but we're going to go in and we're going to create our guest cluster. So I'm going to log in like we saw previously, and giving it the IP address of the supervisor control plane API server. I've logged in now, and I can have a look around. The different contexts, you can see them there. There is one namespace. So, and I'm already set to the context of that namespace as well. So anything I do will be in that namespace context. Now, this is just showing you that we're in the supervisor cluster because we're just looking at the 3 supervisor nodes there. We don't have any virtual machines created. Here are all the images that are in our content library. And here are all the classes that we can use. Again, Frank talked to us about that. So what I'm going to do is I've already created this YAML manifest file for my guest cluster. In this case, I am using the class guaranteed small single control plane once again, with 3 worker nodes. And again, it's very useful to be able to describe these classes because it shows you how much CPU and memory will be allocated to these nodes. Okay, so once more, we'll take one final look at the manifest file and we will go ahead and apply it. So because we're in the context of the supervisor cluster, this goes up to the TKG service, one of the services in the supervisor cluster. And we just give it a little bit of time and we can query various objects associated with this, but we can see that it's in a phase of creating at the moment. Okay, so let's go back to the vSphere client. Let's have a look. We can see the control plane is on its way up. And so the control plane node will be the first one that gets deployed. And then once that has finished deploying, we'll be able to it'll start deploying out the worker nodes. And we can do a kubectl describe to see the state of things are, where a lot of things waiting, like the CNI driver, CSI for the storage interface driver, network interface drivers. But we can speed things up again, and we can see them populating in there. So all of that good stuff. The nodes, again, are pending, so they haven't come up completely yet. but now we should see virtual machines. Remember, we didn't get any virtual machines previously when we did that command, but now we're getting a virtual machine representation for the control plane and the worker nodes. And back on the UI, things are starting to appear. So let's check out. Yeah, we can see actually resources being consumed now within the Cormac namespace as well. So yeah, I think everything is ready. So what we're going to do now is we're going to change context. Remember, the context we're currently in was the supervisor context. Now we're going to change context into the guest cluster. So we can specify the namespace and specify the name of the cluster. And that was the cluster that I built out. There we go. And now if I check which context I'm in, I am in the context of the guest cluster. We can see it there. And so now anything that I do within this context will be against the guest cluster. And you can see even the nodes, which we listed previously, only showed 3 masters for the supervisor, is now showing the 1 control plane node and the 3 workers for the guest. So that's how easy it is to create a guest cluster within the namespace on vSphere with Tanzu. Okay, so I have one last thing I want to talk to you about, and this is something that we announced with the release of VCF 4.2 and vSphere 7.0 U1 as well, but really in the context of VCF 4.2. And the whole point here is that we're now able to provide on-prem services that might be required by your developers within a namespace. So at the moment, we can provide 2 services. One is the Minio S3 object store, and the other is a Cloudian S3 object store. And so essentially what you can do is you can enable these, what we call operators, partner operators within vSphere with Tanzu. This will roll out these different applications. And what you'll then be able to do is create instances of these applications on a per namespace basis. So perhaps somebody is running an example might be Valero to do backup and restores of different objects within a namespace. What you could do is you could provide a Minio on-prem object store to that namespace so that they have a destination to backup and restore to. So the one requirement here though is that it does require vSAN. The one thing I will highlight is that we have a new configuration for vSAN that is available as well, called vSAN Direct, which means that you can actually use devices directly for these applications as well. So you don't necessarily have to use the vSAN protection mechanisms, which allows you to do RAID 1, RAID 5, RAID 6, and so on. What you can do is use a vSAN Direct configuration, which could be directly to an SSD device or PCIe NVMe device or something like that, and consume those directly through the vSAN Direct configuration as well. So just something to think about. It's early days for this particular feature. As I said, we only have the 2 applications at the moment. We were working with a number of other partners, and hopefully over time, we'll start seeing more of these applications become available. And essentially, just to recap, these are deployed inside in the supervisor cluster. These operators are deployed inside in the supervisor cluster, and then you can instantiate versions of these different applications within individual namespaces. Okay, so that's it from me. I see Cedric has a question. Why don't we use the integrated basic load balancer from NSXT instead of HA proxy? Yeah, that's I really don't know the answer to that one, Cedric. Yeah, I think, I mean, you can still absolutely use NSXT, as I highlighted. I don't know why we're not doing that basic functionality. Maybe because we just need too much of the NSXT infrastructure to be stood up just to consume that integrated basic load balancer. Maybe, I really don't know the answer for sure. Okay, I think everybody is still unmuted. I don't know if you feel like, oh, okay. Teddy asks a question. Are there any enhancements brought to the HA proxy? Do we use it in the production environment? Yeah, so I think one of the drawbacks with using the HA proxy, apart from it being a VMware product, is that we can't even make it highly available, Teddy. And so, you know, it's funny that you have a name called HA proxy, but you can only instantiate a single instance of it. And so the other thing I find with the HA proxy, it's very difficult to see what's consuming the different load balancer ranges, things like that. Yeah, the AVI appliance, which is the NSX Advanced Load Balancer, that's how we're marketing it. That has, you know, a full-blown UI where you can see all sorts of, you know, the relationship between what application is using which load balancer service and which IP address and all of that good stuff. So there's quite a bit of setup for the NSX Advanced Load Balancer, but I think it's fairly straightforward. I certainly had a better user experience with it than I did initially with the HA proxy. So, I mean, just to recap, Teddy, we do support you using the HA proxy in production. You can absolutely do that. It's just whether it would meet your requirements in production. So that's the question you would need to ask yourself, especially considering it's not a VMware product and it's, you know, it has some limitations about availability and things like that. I hope that answers your question. And then Matthew asks, I've heard the AVI appliance will be used in the next design instead of a HP. Well, that's in 7.0U2, Matthew. So you have the choice in 7.0U2. And so that's the thing to clarify. In all of these versions, you can still use NSXT. And if you use NSXT, you get the pod VMs, you get the integrated harbor register service, you get all of those. In 7.0U1, you could use NSXT or the HA proxy. Those were the only two load balancer services, service providers. In 7.0U2, you can continue to use NSXT, you can use the HA proxy, but now you can also have the choice of using the AVI appliance, which we are marketing as the NSX Advanced Load Balancer. So you have the choice of all three. Hopefully that makes sense. Timing problem with the HA proxy. It depends. The very first time I tried to set up the HA proxy, it took about a week. I couldn't figure out what they were looking for. I don't think we spent a lot of time on the user experience, if I'm perfectly honest. Using the NSX Advanced Load Balancer, I had it up and running in a couple of hours. So there you go. Can I register vSphere with Tanzu, supervise a cluster behind a proxy? Good question, Bilal. I will research that for you while Duncan is doing his presentation. I've never done it. Frank, maybe have you ever come? No. So I will research that for you, Bilal, and see whether you can actually do that or not.
Interesting question.
Yeah. Okay, I am going to stop sharing and I will allow my esteemed colleague, Duncan, to take over. Okay.
Thanks, Cormac.
Sure.
Well, what applied in the previous sessions, of course, also applies here. If there are any questions, feel free to use the chat or unmute yourself after the session to ask your question. Where Cormac and Frank primarily focused on the cloud native aspect of things, I'm going to bring it back a bit more towards the infrastructure of things. And I'm going to focus on the vSAN side of this equation. Now, the funny thing is that if you look at all of the different platforms that we were talking about, and when you look at things like cloud native applications, a lot of people tend to refer to cloud native applications or these architectures as 12-factor architectures, microservices, et cetera, And then when they talk about those different types of things, they will also typically mention that the legacy world is a 3-layer cake, with that 3-layer cake, of course, referring to the application architecture of the past, where you have a front end, some application layer, and the database sitting beneath that. Of course, by a lot of people, that 3-tier architecture is also for infrastructure referred to as legacy, where they typically refer to having separate storage, networking, and compute components. Now, the funny thing is that if you look at the architecture that we are presenting here, and if you look at the architecture that the majority of people have implemented, whether that is in public cloud or in a private cloud, and whether it is using VMware technology or is not using VMware technology, again, we actually end up with a 3-layer architecture. And that 3-layer architecture, in this particular case, I'm not just referring to the components that are used, but I'm referring to the people that are leveraging these components. Because when we started out, Frank actually primarily addressed the developer side of things, and the developer actually consumes these Kubernetes clusters. Now, the Kubernetes clusters are typically managed by the DevOps team, and they typically end up managing, in our case, vSphere with Tanzu, the vSAN data persistence platform, and of course, our cloud native storage control plane. Now, of course, there's a third aspect as well that comes into play, which is where the virtualization administrator becomes extremely important, and that is both vSphere as well as vSAN. Now, for vSAN, of course, there are many different aspects that come into play when we start talking about these cloud native applications. But of course, the platform is not only suitable for cloud native applications, it's actually being used by over 30,000 customers to host regular traditional virtual machine workloads. And those could be things like, of course, VDI desktops, but of course also all sorts of enterprise applications. Now, when we talk about vSAN specifically, I'm just going to do a brief introduction of what it is, what it looks like, so everyone is more or less on the same page. And when we talk about vSAN, we refer to it as an enterprise storage solution, and to be more specific, an enterprise object-based storage solution. Now, it's not similar to S3 type of object storage, and I'll show you what it looks like in a bit. But just going over what it looks like from an architectural perspective, vSAN is a storage solution that is baked into vSphere itself. So basically, if you as a customer understand how to manage a cluster, HA and DRS, you will probably also be able to configure and manage vSAN. Now, there of course are a couple of other things that come into play when it comes to managing vSAN, and that primarily relates to the type of devices that are being used. When you enable vSAN, what we'll end up doing is, or what vSAN ends up doing is, it will grab all of the local devices, those could be flash devices or spindles, and then it will create a single shared data store out of those local devices to the cluster itself. So there's a direct relationship between the cluster, a one-to-one relationship even, between the cluster and the local vSAN data store. Now, as soon as you have that vSAN data store up and running, of course, you can start provisioning your virtual machines. You can run your cloud native applications on top of it, or you can start creating things like file shares or iSCSI LANs, or whatever is required in your environment. But when you start creating those virtual machines or cloud native apps, there's one important aspect that comes into play, and that is how you manage these type of entities. And entities in this particular case, I'm referring to virtual machines, cloud native apps, iSCSI LANs, file services, file shares, or whatever it ends up being. Whenever you create one of these things, you typically assign a policy to that object. Now, when you assign a policy to a virtual machine, that policy basically contains how the virtual machine should be provisioned, what type of data services should be enabled for the virtual machine, what kind of performance you could expect for the virtual machine, if the virtual machine needs to be stretched across locations, all those different things can be specified within a policy. If for whatever reason, the requirements of your virtual machines or your application or your cloud native app or whatever it ends up being changes over time. So let's say the application owner phones up and says, you know what, I'm running this application on your cluster, but it's now only running in a single location, but I would like to have it stretched across multiple locations. Is that possible? Well, then what you will end up doing is you will simply change the policy on the virtual machine. So you don't pick up the virtual machine and move the virtual machine from one data store to another data store. but you just simply change the policy that is associated with that virtual machine, and magically or automatically, I should probably say on the back end, vSAN will start redistributing the data based on what is specified in that new policy. Now, when it comes to the placement of the data, there's one thing which I think is important to understand when it comes to vSAN. vSAN is a distributed storage solution, but it's a distributed object-based storage solution. So it's not a distributed file system. With vSAN specifically, every single disk group or every single disk that is part of that disk group has its own file system. The great thing, of course, about this is that if something happens, to one of the disks or to one of the file systems in one of the hosts, it will not automatically spread out to the rest of the cluster. The other thing as well is that because we have this mechanism, we can leverage that storage policy-based capability and specify within policy how many components or how many copies I would like to have of the data. So if I look at my virtual machine, and my virtual machine is typically, or my virtual disk is typically what we would refer to as an object. When I specify within a policy that I would like to have a RAID 1 configuration and would like to be able to tolerate a single failure, I'm going to create 2 copies of the data for you. So better said, vSAN is going to create 2 copies of the data for you. On top of that, as you can see in this particular diagram, besides having 2 copies of the data, you will also have a witness component, and that witness component comes into play in case there's a quorum mechanism needed to identify or to figure out who has ownership over the data when something has happened to the network or one of the components has failed. So that's why we have that witness component there. Now, of course, depending on what you've specified within the policy, you may see 2 copies of the data. Potentially, you could see 3 copies of the data, or maybe you will see a RAID 5 or a RAID 6 configuration where we actually use parity blocks instead of having multiple identical copies of the data. So again, based on what's specified within the policy, the data is going to be laid out in a particular way in your cluster. Now, not only do we have the ability to specify on a per VM basis what should happen to that virtual machine, we also have the ability to specify on a cluster level which data services should be enabled. Now, when I'm talking about these particular data services, I'm going to be referring to things like deduplication, data at rest encryption. In 7.0 update 1, we also introduced compression only and data in transit encryption. And of course, we also have things available like the vSAN iSCSI target service and vSAN file services. Again, these things are all enabled on the cluster level. There's no option to enable these or this on a per VM basis at this point in time, but you can imagine that this is something that we potentially could consider at some point in the future as well. Now, the interesting thing with vSAN is the following. Not only are you capable to specify within a policy what or how the data should be provisioned, we also have the ability to specify within the UI what the data center looks like. So if you're one of those customers that has multiple racks, maybe multiple chassis, potentially even multiple data center rooms within the same building, or maybe even different data center buildings on the same on the same campus with extremely low latency, you can now specify within the UI that you have several fault domains. And then when vSAN starts provisioning the virtual machines for you, what is going to happen is that it's going to take that data center layout, that data center infrastructure into account. So if you have multiple racks, it will ensure that copies of the data are spread across those multiple racks. So in the case a single rack fails, a single room fails, or potentially even a whole building fails, we can still run those virtual machines elsewhere. So we have that ability available within the UI simply by specifying what the data center looks like. And I'm going to show that in a second, how that actually works. Now, let me show you straight away, right? So if we have a vSphere environment, as you can see, we have a cluster available here. What we can simply do is we can start creating a new cluster. So let's go ahead and create a cluster object. We click new cluster. We can simply enable the services that we would like to have enabled. In our case, that can be, or that's going to be DRS, HA, and vSAN. And then after we've created the cluster, what is going to happen is we're going to be pointed to the quick start wizard. Now, this quick start wizard is something that we've introduced not so long ago, and it basically enables us to quickly create a vSAN cluster. I can add existing hosts to the cluster. So I'm going to add 4 hosts to my cluster simply by selecting them, or I can add new hosts as well if they are available and they're not part of vCenter server yet. Simply click next, next, finish, and those hosts that were just part of my data center have now moved into my cluster automatically. After they've been moved into the cluster, we're going to verify that they are healthy. And then after we've verified those checks, we can now simply click on configure and start configuring all of the different services that are available within my environment. So when I click configure, I can, for instance, configure the network. Now, in my case, the network is already configured because this is something that I do fully scripted. But if you would like to do that, you can also do that, of course. Now, besides being able to create a single cluster, I can also create a stretch cluster. So I select the deployment type stretch cluster. I'm going to click next. The disks have already been claimed for vSAN, so I don't need to do that specifically. And then the next thing that I will need to do is I will need to set up these fault domains. Now, in this case, these are buildings. So I'm going to move over 2 hosts to the right side, and I have, of course, 2 hosts on the left side as well. Then the next thing I will need to do is I will need to select a witness host. This is not the same as the witness object that we've just seen in the diagram, but this is a host that is located in a 3rd location, because this is a stretch cluster that I'm creating, which will allow us to figure out, if something happens between the network of those 2 buildings that are hosting data, that basically will allow us to determine who has quorum or assign quorum to one of those 2 locations. Now, those hosts are going to be added to the cluster. We are creating the fault domains automatically, of course. And then after the fault domains have been created, the witness will be added will be added to the cluster as well. And then after that has been done, what we can do is we can simply start creating policies, or of course, we can start provisioning virtual machines. So pretty straightforward mechanisms. As you can see, we have those 2 fault domains available in the UI, and that's literally all that it takes to create a vSAN stretch cluster. Now, for those who've never created a stretch cluster before up to now in the life, I've created many of them, both NetApp, Dell EMC, HPE, IBM, you name it. I can tell you, none of those solutions will provide you the ability to create a stretch cluster in literally, under 15 or 20 minutes. This is all that it takes from a UI perspective. Of course, there's more that comes to it when it comes to networking, but from a storage perspective, vSAN stretch clustering is extremely easy to set up. Of course, when you don't have a stretch cluster, it's even easier because you can simply skip the fault domains if you don't want to create those fault domains specifically. But this is what it takes to create a vSAN environment. Now, besides being able to create a vSAN environment, of course, you're also able to scale a vSAN environment, grow a vSAN environment. And a vSAN environment, you can grow that fairly easily. You can add disks to existing hosts. You can add multiple disks, which we typically refer to as disk groups, to a single host. You can add hosts to a cluster. But of course, you can start creating additional clusters as well. Now, one of the things that people always ask is, okay, but what about sharing capacity between different vSAN clusters? Is that something that is possible as well? You can imagine that if you have, very active developers potentially creating many containers or, cloning many different VMs, that one of the clusters could be running out of disk space. So how can I leverage the capacity that is available in one of my other clusters? Well, that is actually something that we've introduced as part of vSAN 7.0 Update 1. And this feature is what we refer to as VMware HCI Mesh. And with VMware HCI Mesh in 7.0 Update 1 specifically, you're now able to share vSAN capacity between vSAN clusters. So what you can do is you can go to the UI, click on Mount Remote Data Store, and simply mount a remote data store between all of the different clusters. Now, this gives, of course, the benefit, first of all, that you can leverage the capacity that is on that remote data store. But secondly, you can also start moving virtual machines around just from a compute perspective, if that is something that you desire to do so without actually moving the storage, because it's all mounted across. Now, I've mentioned that this is only available in 7.0 Update 1 between vSAN clusters, but of course, what we did with vSAN 7.0 Update 2 is that we actually made this available for customers who have compute-only clusters. So if you're one of those customers that has a couple of compute-only clusters, which clusters that don't have local vSAN storage, and you have vSAN clusters available as well, and you would like to share that vSAN capacity, starting with 7.0 update 2, you can simply go ahead and do that. So you can have a compute-only cluster. You simply can enable vSAN, and then when you have mounted that vSAN capacity, you can start provisioning your virtual machines. Now, let me show you what that looks like, because I think it's, it shows the power of the environment. In this particular case, we already have vSAN configured on my vSAN cluster itself. So it's already running vSAN. It has sufficient capacity. And I have a compute-only cluster in my environment as well. So in this case, what I'm going to do is I'm going to click on the compute-only cluster. I'm going to click on services and then configure vSAN. I need to configure vSAN because I need to load the vSAN client on this compute-only cluster. So there's an option at the bottom that says vSAN HCI Mesh Compute Cluster. I'm going to go ahead and click that. Now, when I click Next, Finish, the vSAN client is going to be loaded on the hosts in that cluster. After it has been loaded, what we can now simply do is we can mount remote data stores. So I can click on Mount Remote Data Stores. And after I've clicked Mount Remote Data Stores, of course, I will get the option to mount my vSAN cluster. So click Mount Remote Data Store. The vSAN cluster is going to pop up. In this case, I only have a single vSAN cluster. If there were multiple, I could, of course, select another one as well. I can click Next. And now that vSAN data store is going to be mounted automatically to the two hosts in my compute-only cluster. There are a couple of checks that we are doing to figure out if you're not exceeding a certain amount of latency, et cetera, et cetera. Of course, you'll need to make sure you stay within those boundaries. If you stay within those boundaries, the data store is going to be mounted. And of course, when the data store has been mounted, you can start leveraging the data store by simply provisioning virtual machines to that data store. Now, a couple of things I want to mention here. In this case, it's compute-only cluster, so I can simply leverage the vSAN data store capacity. You could have a combination of hybrid and all flash, for instance. If you have a hybrid cluster, you can still provision virtual machines to that all flash environment. You can even leverage the RAID 5 and RAID 6, even though it's not available locally. It does not mean that you can't use it remotely. So I think that brings a lot of flexibility and agility to the average vSAN environment. Of course, after we've provisioned the virtual machines, if I would click on the virtual machine, I could also see that it's provisioned remotely. So I can look at physical disk placement and actually tells me where it is being placed. The last thing that I want to show you is a change that we introduced from a policy perspective, because now that we have this HCI mesh capability, you can imagine that you should also be able to specify which data services should be enabled on a cluster level. So some clusters may have encryption enabled, some may not have encryption enabled. So if you're one of those customers that has a mix of those, you can also specify within policy that encryption needs to be enabled for the virtual machines that will have this policy assigned. So that is something that we've introduced as vSAN, as part of vSAN 7.0 update 2 as well. Now, that was the HCI mesh part of things. And another couple of things that I do want to mention from a architectural, infrastructure perspective. I think there's probably two max configuration items that are important to understand. First of all, a single data store can only be mounted to a maximum number of 128 hosts. So that is something that is important to understand. If you're one of those customers that has many different clusters with many hosts, then you will need to limit the combination, the number of clusters connected to each other. The other thing that is also a limit, you can only mount a maximum of 5 remote data stores to any given cluster. So that will probably also limit the number of hosts you will have associated with it. Of course, there are a couple of things from a networking perspective that we do recommend. Both layer 2 and layer 3 are fully supported. From a bandwidth perspective, we do recommend customers to use 25 gig NIC. So that is something that you need to take into consideration as well. Now, talking about these different ways of scaling and different types of use cases for vSAN, of course, there are other ways you can use vSAN as well. And one of those ways that you use vSAN is for cloud native applications, not just for cloud native applications, of course, also for running other types of workloads that may require some form of file share. this is probably one of the most requested features that we've had over the past, probably 4 or 5 years. But as you can imagine, creating a distributed file services solution does take a significant amount of time. That's why, it took us all the way up to vSAN 7.0 before we actually started, or before we introduced vSAN file services. Started with vSAN 7.0. We introduced support for NFS version 4.1 and NFS version 3. With 7.0 update 1, we've actually introduced support for SMB version 2.1 and version 3 as well. And on top of that, we've also introduced support for authentication for NFS via Kerberos and SMB through Active Directory. So if you're one of those customers that requires authentication, make sure to look into vSAN 7.0 update 1. Now, as I've mentioned, of course, we do support running all types of workloads on top of vSAN file services. What I've seen customers using it for right now is mainly for cloud native applications, traditional applications, and of course, we've also seen some customers using it for user directories, for instance. With 7.0 update 2, for those customers who have a stretched cluster configuration or a 2-node configuration that would like to use vSAN file services, we also introduce support for vSAN file services for those types of configurations. This is not supported with 7.0 update 1. So if you would like to use vSAN file services and you have a stretched cluster configuration, make sure to use vSAN 7.0 update 2. The reason it's only supported with 7.0 update 2, it's not just the testing exercise. The reason we support it with 7.0 update 2 is because we introduced a couple of changes in the user interface that will actually allow you to specify to which location certain IP addresses of your distributed file services solution belong to. And this is basically to avoid the situation where you have workloads running on site A, which are actively accessing file shares which are located on site B. So you want to prevent having those hops across the network. So that is something that we've introduced in 7.0 update 2. On top of that, we've also introduced with 7.0 update 2 snapshotting capabilities. You can snapshot via the APIs. And this is basically introduced for our backup partners so that our backup partners can be more efficient in terms of how they back up these file shares that we are presenting. Now, how that has been implemented, and I think this is interesting to show because this is something that a lot of people have questions about. If you look at how it has been implemented, it's slightly implemented in a different way than the majority of other solutions that you've seen with vSAN so far. As I've mentioned at the start, vSAN is fully integrated with vSphere, and it's actually integrated on the kernel level. Now, if you look at vSAN file services, it has been implemented in a slightly different way. If you would have an NFS client or an SMB client for that matter, and you connect to an NFS or an SMB server, of course, that NFS or SMB server needs to run somewhere. So that's going to be running on top of vSphere. Now, the interesting part here is that it's not integrated as part of the hypervisor itself, but it's actually running as a container within a virtual machine. Now, I mentioned that it's running as a container within a virtual machine. You can imagine that over time, that virtual machine is going to be disappearing, and that container is going to run natively on top of the hypervisor, which is what Frank was also discussing. Now, do mind that vSAN and the ESX Agent Manager actually takes care of the deployment of these virtual machines. And of course, we will operate those virtual machines as well. And the file services that sit within between, if that is something that you would like to do. So we have that capability available within the UI as well when it comes to updating. Now, when you start creating these file shares and you associate a policy to the file share, of course, we will need to start creating these objects, similar to what we would have for a regular virtual machine. Now, vSAN is responsible and the SPBM layer is responsible for creating those objects. And as soon as we have those objects created, what is going to happen is that all of those objects are going to be formatted with a virtual distributed file system. And that virtual distributed file system is then going to be presented as NFS or SMB to the client that would like to connect to that particular file system. One thing I want to point out here is something that may not be immediately obvious. In the middle of the diagram, it says vSocket or VMCI. And this is actually the mechanism that we are using, or that the file services solution is using to communicate with the hypervisor. So we're using a special PCIe interface within the virtual machine that allows us to directly communicate with the hypervisor. So it's an extremely efficient data path to the hypervisor itself and to the objects itself. So this is something that I think is important to understand as well for those who are wondering if there is any kind of overhead. There is no particular overhead when it comes to this implementation because we leverage that vSocket or VMCI interface as it's called these days. Now, if you look at how we've implemented that, let me basically show you what it looks like. In this particular case, we already have vSAN enabled. What we have enabled in this particular case also is a stretch cluster configuration. And now what I'm going to do is I'm going to show you what we have available when it comes to the creation of a vSAN file services environment. So I'm going to enable vSAN file services on this stretch cluster configuration. First of all, simply click enable, and then I'm going to step through all of the different aspects of the configuration. The OVF has already been downloaded, so I don't need to do that. I'm now going to specify a file services domain name. This is basically a namespace for vSAN itself. I'm going to specify the DNS suffix and, of course, the DNS service for my environment. After I've specified that, I need to make sure that the vSAN file services solution is going to be connected to the network. So I'm going to select the port group. We'll specify the subnet mask and the gateway. Now, do note the port group that I've selected will automatically have promiscuous mode and forward transmits enabled. So make sure you use a dedicated port group for this solution. After I've specified those details, I can simply add my IP addresses to the environment. If they are subsequent IP addresses, I should be able to click autofill. In my case, that wasn't the case, so I need to fill those out. Then I can click lookup DNS, and it's going to automatically add all of the DNS details. Now, this is the important thing when it comes to stretch clustering. In this particular case, what I'm going to do is I'm going to give every single IP address affinity with a particular location. That basically means that the container that has this IP address assigned will be running in this particular location. So I'm going to specify whether it should be running in the preferred location or in the secondary location. And of course, I'm going to do that for every single file services IP address that is available. Now, this is not mandatory. Keep in mind, you could also have this randomly. If you don't care about the latency overhead, then just say either, and it's going to automatically distribute it for you. But in this case, I would like to have a bit more control over how I'm accessing the data. So I'm going to specify that particular IP addresses should reside in one location and that other IP addresses should reside in the other location. If, of course, one of the locations would fail, my vSAN file services containers would still be available in the other location, and they will automatically rebalance as well. Now, after my vSAN file services is created, of course, I can start creating file shares. So that is what I'm doing here. Now, mind you, I've just gave it a name. I'm going to stretch all of the data across my locations, and then what I can do is I can specify with which site my vSAN file share should have affinity with. So that basically determines to which IP addresses this file share will bind itself, right? In this case, I'm going to select preferred, which means it's going to be binding itself, or it's going to have affinity with the IP addresses that are within the preferred location. I'm going to set a threshold as well. So simply that I get a warning if someone is exceeding the capacity threshold, and after I click next, finish, I can simply start connecting to that file share. Of course, the virtual machine that should connect to that file share should also be, preferably located in that preferred site. So that is something, as I mentioned, that we've introduced as part of vSAN 7.0 update 2. As you can see, we can look at the details. We can even see that the data is stretched across locations. It's actually stored on all of the different hosts within my environment in both sites. But from an access perspective, we should access it through the preferred location. So hopefully that makes it clear what we've introduced for vSAN file services in 7.0 update 2 specifically, but also hopefully it shows you how easy it is to configure and how flexible you are with vSAN 7.0 update 2. Now, Besides being able to leverage your environment for vSAN file services, besides being able to provision virtual machines, of course, there are a couple of things from a management perspective, which I think vSAN is also extremely good at. But first of all, I think one of the things that we've introduced not too long ago, which is very interesting and very useful, is vSAN IO Insight. Now, for those, some of you may have heard about vSAN IO Insight before, and vSAN IO Insight is basically a mechanism that allows us to trace a virtual machine from an IO perspective. We've introduced this capability a long time ago as a fling, but as you know, flings are not officially supported by VMware. So what we have done with 7.0 update 1 is that we've actually introduced the solution within vSphere itself as a feature. Now, the great thing about this solution is that you can simply click on the VM or click on an object and start tracing the virtual machine and then start inspecting the data. Let me just show you what it looks like, because I think it immediately shows you the power of vSAN IO Insight itself, as it's extremely easy to use and it provides a lot of useful data. When I right-click an object, that could be a cluster level, that could be a virtual machine, I can start a new vSAN IO Insight, and I can simply select the instances or the virtual machines that I would like to monitor. In this case, I'm just going to monitor a single virtual machine. It's going to be my vCenter server, and I'm going to monitor that for 10 minutes. Of course, that could also be for 24 hours, of course, depending on what kind of time frame you're looking to monitor for. Now, keep in mind that the data that we are gathering is going to be stored in the vCenter server itself. So that is something to keep into consideration. The longer you're monitoring for, the more data, of course, you will be storing. While it's being traced, you can go to the cluster, go to monitor and performance, and there's an option here called IO Insight, and you can see the instances that are being traced right now or that have been traced in the past. As you can see, my instance is still running for 9 minutes, so we're going to speed up the video, and then after hopefully a few seconds, we will be able to start looking into the details of what we've just traced. Besides being able to look at the details, we can rename the trace, we can delete the trace, or we can even rerun it. So if we would like to rerun it, we have that option as well. But I think the most important thing, of course, here is view metrics. When you click view metrics, we will take you to all of the details that we've collected for the virtual machines. Not just are we collecting things like IO, IOPS, throughput, but also things like whether you have sequential versus random IO, what the IO ratio, sequential versus random IO ratio is, whether the blocks are 4K aligned or not, what the read-write ratio is, what the IO size distribution is, and even what the latency distribution is. So all of that information is available for the virtual machines and for all of the different virtual disks that are part of that virtual machine as well. So it immediately, hopefully, makes it obvious, what is happening in your environment, what kind of IO is occurring within your environment, and potentially, that may allow you to do some form of troubleshooting with that as well on top of that. Now, when you look at that information, I think it is extremely useful, but that's not what we're going to stop. This is not something that is available as is right now, but this is something that we are considering to make available in the near future. And that is something that we refer to internally at this point in time as the IO trip analyzer. As you can imagine, with the IO trip analyzer, we would have the same one-click analytic capability that we've just seen. We will still be able to provide you all of the different information around the IO patterns, what the read-write ratio is, et cetera. But more importantly, what we will also be able to do is show you that information in a different way. And that being, all the way from the disk, from the virtual disk down to, the capacity tier where we're storing the data on. And I think the interesting thing here is that we will be able to see on each individual level what the latency is that is introduced. So if there's latency introduced from a networking perspective, from a disk controller perspective, maybe it's the caching tier or the capacity tier, you will be able to see that information using the IO trip analyzer in the future. And I think that is something that will be, very useful for customers in the future when it comes to troubleshooting their environment. With that, we've reached the end of my part of the session. I noticed there were, not too many questions in the chat. I think Cormac already answered the question in the chat, but if there are any other questions, feel free to ask the questions either by unmuting yourself or by asking a question in the chat specifically either on this topic that I've just discussed or any of the other topics that Cormac and Frank discussed in the past 2 hours. I didn't miss any questions, right, Cormac?
No, Cedric was just asking about the ability to mount a vSAN data store directly to a single standalone ESXi host. He has a use case, but he's going to send me some information via email. I think it might be good for us to understand that.
Yeah, I think it's a valid question. Right now, you need to have a cluster available, so it's not possible. But I can understand where the question is coming from. So we may be able to, if you provide us the use case, persuade the engineering team and the product management team to look into it. So if anyone else has other use cases for it, please let us know. I don't know if there are any other questions that people have. And if there are no other questions, we can always hand it back to the VMUG leadership team.
Everything seems be clear. Thank you again, Duncan, Cormac, and Frank. It was a great VMUG webcast today. It was a mix between demo and slides. I very appreciated this roadshow. Thank you again, guys. Please, my friend, if you have any question, ask now for speaker. You can switch on your microphone if you want.
And if there are no questions right now, and you think of something in the afternoon or whatever, tomorrow, whatever it ends up being, feel free to ask us the question on Twitter or connect on LinkedIn or YouTube or whatever. It's we're available through many different channels.
Okay. Thank you. Thank you again, guys. I think that the VMUG community in France very appreciate this session. It's always a pleasure to get Frank, Cormac, and Duncan here. Please, if you want, if you have any topic, subject, if you want to share with the community, please feel free. Take this the stage on the VMUG community. It's always a pleasure.
Thanks, everyone.
Thank you, guys. Bye-bye. See you. Take care.
Au revoir.
You too.
Bye-bye. Au revoir. Thank you again.